Okay, so what I was asked to was question 21. I'm asked to find the shaded region of the outside. So what happens is I basically have two circles. I have a circle of 8. I've removed that out here, and then I also have a circle of 12, which is this one here. So what I do is, if I get the big circle and take away the small circle, I basically find what I'm looking for. The area of a circle is pi r squared. The area of the smaller circle is also pi r squared. However, they have different r values. So it's going to be pi times 12 squared minus pi times 8 squared. That is going to be 144 pi minus 64 pi. The answer therefore will be 80 pi. Put 80 pi into the calculator. You can change the value, and what you get is 151.33. Now what's the units, guys? 251, sorry. 251.33. Is it centimeters, or doesn't really tell you, does it? So it's an area, right? So you write down units squared. If it's measured in centimeters, it'll be centimeters squared. If it's measured in meters, it'll be meters squared. It's a centimeters, is it? Okay. I put 80 pi into the calculator, and it gave me that. I can just put all this straight into the calculator, and it'll give me the 251 now. No, it has to be 3, because it rounds down, not up. 32 is close to 3 than it is 40. It's okay. Yes. Okay. Shh. Now, rectangular piece of metal, guys. Okay. Shh. We're asked to find the length L. The length L is this length here. Okay. So what we can say from the length L is that the length L is the same as the diameter of a circle. The diameter of a circle is twice the radius. It means it's 16 centimeters long. Calculate the area of the metal not used, the shaded section, giving your answer in terms of pi. Well, what I should do is I should get myself the size of the rectangle. Area of rectangle is what, guys? What's the area of a rectangle? Length by width. So what's 16 pi multiplied by 16? Let's go for 196 pi. Okay. Now, 16 multiplied by 16 pi. 256, is it? Nuts. Okay, 256 pi. Now, oh, I did 14, not 16. Okay. Shh. Excuse me. Now, what we have here, guys, is the circle. So you take away 2 circles from our 256 pi. The circles are radius 8. So it's pi times 8 squared. Pi times 8 squared. One of them is 64 pi, because pi times 8 squared is 64 pi. And that's also 64 pi. 256 pi minus 64 pi minus another 64 pi. And put that all into the calculator, and you find out that the area that remains is 128 pi. Is that right? And you put that into the calculator, 128. The pi button is located in yellow. Means you press the shift button to access it. There we go again. Shift button to access it, and you get 402.12. What's this measured in? It says centimeters there, so it's measured in centimeters squared. Now, express the area of the metal not used as a percentage of the total area. The total area refers to the sheet of metal before anything was cut out of it. So that's our 256 pi. What remains is 128 pi. And now you're going to multiply that by 100. So roughly how much of it did we use? Half it, wasn't it? So half multiplied by 100 gives you 50%. You could also just enter all of that into the calculator, this whole thing as it looks, and it'll just turn out the answer to be 50 or 50%. Yes, Sean? The class, identify what is the object PQRS. It's a trapezium. We're going to get the area of the trapezium and we're going to take it away from the area of the circle. That's the plan. So let's start off with the area of the trapezium. Where can you find the area of the trapezium formula in your maths tables? Probably go on to page 8. And what you'll see is you'll see a trapezium. What is a trapezium again? Two parallel lines. The two parallel lines are separated by a distance h. A is the length of the top line, B is the length of the bottom line. To be honest guys, A and B are interchangeable. It doesn't have to be the longer one. Just look at the two parallel lines, call one of them A, call one of them B. That's all you have to do. So look, A is 9, B is 6. What's the h value separating the two lines? 11. Then you look up the area formula, which is half, if I remember this, wait, it's presented differently. It's A plus B over 2 times h, right? Okay, so it's going to be 9 plus 6 divided by 2, multiplied by 11. What you get? 7.5 by 11? 82.5 maybe? There we go. 82.5, it's centimeters, so we have to specify centimeters squared. Okay, then all I gotta do next is I go back to the circle and I look at the circle and I figure out the area of the circle. So what's the area of the circle, guys? Pi r squared. What's the radius of said circle? 7. So pi times 7 squared, which is 49 pi, which is 153.93. I wouldn't round off just yet. Only round off at the very end. What? 938. The 0 is so small that it's insignificant. Okay. Now guys, one take away the other. The 153.938 minus the 82.5. What you get there? 71. I don't think it's. I think there's a slight round off error there. So yeah, see, it won't be 0.5 because it's 438. Like 438 is close enough to 44. But what I'm trying to say is by rounding off, not at the very end. See, that's 71.44. To one decimal place, it's 71.4, not 71.5. That's where you lose 2 marks, is when you end up rounding up instead of down. Okay, so that's where you can lose it. So my recommendation, unless otherwise specified, always 3 decimals or 2 decimals until the end, and then round it off to whoever you want. Never round it off to 1 decimal, never round it off to the nearest number, unless you're answering the actual question. It's got to be the very last calculation. Okay, so just hopefully that point is made there. Okay, so 71.4 centimeters squared, and we're done. Last one, and they love these types. They love these ones. Okay, you have a 400 meter track. Okay, this is a standard Olympic track. So if you have the 800 meters in the Olympics, they're going to run 2 laps. If you have the the 400 meters, you're going to run 1 lap. Okay, so what we have here is the diagram shows the perimeter of a running track consisting of 2 straight sections. So that's L, that's also L, and then 2 semicircular sections, each of radius. So the radius of the circles equals 100 over pi. Given the perimeter of the track measures 400 meters, find L. What I'm going to do first, guys, is do the more complicated part. I have to find the length of the red parts. Okay. Now I'm going to do it as a semicircle. You could join them both together as a circle and do it that way, but you need to know how to get the curve of a semicircle. There's a formula in your notes. Can anybody identify the formula in the notes to get a length of an arc? It's a long formula. Theta over 360. Does the 2 pi r come in front of it or behind it? Sorry? Now, that seems like complete and utter random gibberish, alright? But let me show you where it actually comes from. See, what happens is, when you have that's the length of an arc, okay? When you have a circle, like a full circle, okay? When you do a lap of a full circle, how much is it worth? If r is the radius, how much is a full lap of a circle worth? 2 pi r. Is that alright? 2 pi r gets you the full lap. Okay? Now what happens in many questions is that we don't complete a full lap. We might only complete, let's say, 60 degrees. Okay? 60 degrees is this much. So we roughly only complete the blue section. Is that alright? The blue section. So now what happens next is this, guys, okay? That's 60 degrees, okay? Now see this theta over 360 business. That basically will turn into 60 over 360. What is 60 over 360? 1/6. That means that this particular slice, there would be 6 equal. Is that 1, 2, 3? There'd be 6 equal slices. Would you agree with that? And that each blue length should be the same. So you've basically cut your length into 6 equal parts. So that's why the theta over 360 exists. Because you don't want the full length, you want 1/6 of the full length. Now in this particular question, we're not dealing with a sixth. What are we dealing with? We're dealing with a semicircle. So in a semicircle, what angle are you looking at in a semicircle? 180. So instead of having 360 degrees, you're now going to have 180 degrees. 180 degrees corresponds to this blue section here, which is half of it. So when you put in 180 divided by 360, what that does is it basically halves your entire length. Now what's the entire length for this one? It's going to be 2 pi multiplied by the radius. So what's the radius of our particular semicircle? 100 over pi. So it's going to be 2 pi multiplied by 100 over pi. And then we say, okay, what's the angle? That's 180 degrees, half of a 360. So that will be 2 pi, 100 over pi, 180 over 360. You put that into the calculator, and I'm pretty sure you will get, I'll just take the lazy way out, I'll use the calculator. So what is it, 2? What you get? 100? Yeah, that's perfect. It's 100 meters. So look at this, guys. This means our track is actually split up into perfect section. So see this, that's going to be 100 meters. This part here also going to be 100 meters. What's the length of our track again? 400 meters. So what does it mean about the two home straights? They're going to be 100 meters each. 100 meters here and 100 meters here. Hence we've calculated the value of L. We've done part 1. The 1500 meter race starts at a point A and goes in the direction A, B, C, D. At what point does the race finish? Okay, this is reasonably easy. You just start here and just keep counting. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1100, 1200, 1300, 1400, 1500 right there. Now, a quicker way of doing that would be, what's at the point D? A quicker way of doing that would be to count up in 400s. So you go 400, 800, 1200. At 1200 you return back to A, and then it'd be 1300, 1400, 1500. Imagine if I asked you, where does a 10,000 kilometer race end? Or something that's not divisible by 400. You're not going to count up every section. So you're going to have to count the laps and then try and figure out what happens on the last lap. An athlete completes this distance in 3 minutes and 26 seconds. Find her average speed in meters per second to the to 1 decimal place. Anybody remember speed over time? Speed over time, anybody? So speed equals distance over time. You want it in meters per second, so meters is grand, it's 1500 meters. How many seconds in 3 minutes 26 seconds? So it's it's 3 multiplied by 60 to get you your 3 multiplied by 60 to get your 180 seconds, plus 23, and that will get you 203 seconds. Oh, sorry, plus another 3 because I only added on 23. 206. Okay, 206. Sorry about that. So, guys, what's one of them divided by the other one? Let's just keep doing that. Okay, so 1500 divided by 206. And what do we get? 7.28. She's actually going 7.3 meters a second for 3 minutes and 26 seconds.